Alright, this is lesson chapter 5.5 and a little bit of 5.7 as well. We're going to talk about similarity and scale in this particular section. And similarity and scale are based off something that we already learned, and that is proportions. So can someone tell me what is a proportion or what makes a proportion? Well, hopefully someone said that a proportion is a set of ratios that are being compared and they're equivalent. This was from our previous section. So two ratios, and hopefully you'll remember what a ratio is. When we have similarity or a scale, there's a proportion at play. So if two items are similar or two items are to scale, that also implies that those two items are proportional to each other. So if two objects are given to you and you're told that they're similar or they're to scale, that means there's a proportion within them, and the proportion is comparing ratios within those two objects that are equivalent. Now, if you're asked to look at two or three objects in the case where I'm going to give you, and asked to find the ones that are similar to each other or they are scaled, you're going to compare ratios to see if they're in proportion. Let's take a look at the triangles that are at the very top here. And I have three of them for you. And you are asked by me to see which of the three are similar to each other and which of the three are scaled. So you're looking to find out triangles that have the same proportion. The ratios are equivalent. All three of them have different sides. This one has sides 6, 8, and 10. This one has sides 3, 4, and 5. This one has sides 4, 5, and 6. So just by looking at them, they look different. They'll have different sides to them. But you learned that you can have two ratios that look different, but they are actually equivalent once you simplify them down. So that's one way we can go about it. We can simplify down a ratio or a set of sides in this triangle, and then we can compare that particular ratio to one of the other ones to see if they match up. So let's do that. Let's do that. Let's take a look at this triangle here. And here's a trick. I have three sides. You only have to pick two. If two of the sides are in proportion, the third one has to be. It's forced. So you only have to compare in a triangle two of the sides. And if two of the sides are proportional to those two exact sides on another triangle, you're good to go. You don't have to worry about a third side. It will follow. It doesn't have a choice. So in this triangle right here, let's pick the smaller sides, the two legs. We could have picked the hypotenuse, the longest side, but doesn't really matter. Let's pick the two small sides. 5 to 4. So I'm going to write that ratio here. 5 to 4. For this triangle here. You could have picked 4 to 6. You could have picked 5 to 6. Any of the two legs. Doesn't really matter. Now let's take a look at this triangle here. I'm going to pick two sides, but I have to pick the exact same sides as I picked for the other triangle for this to work. I picked the two legs here, putting the middle leg on top, the small leg on the bottom. I'm going to do the same thing here. 4 over 3, middle leg over the smallest leg. Let's compare the two. I don't have to cross multiply. Same ratios? No, not the same ratio. Right off the bat, I can say these two triangles are not similar, they're not to scale, they're not proportional. Let's take a look at this one. Same thing I'm going to do. I'm going to take the middle side, put it over the top side. Again, initially I could have picked any side and I could have put whichever one on top, doesn't really matter, but I just have to keep it consistent when I compare the objects. So here I'm going to go ahead and choose again the middle on top. Right up here. Oops, sorry. 8 and then 6 on the bottom. All right. Is that the simplest form? No, it's not. I can simplify that down. What could I cancel out from both top and bottom? What do they have in common? A 2. The 8 is 2 times 4. The 6 is 2 times 3. I can cancel a 2 from both, which means the simplest form here is 4 on top, 3 on the bottom, because I can cancel a 2 from the 8 and I can cancel a 2 from the 6. Now, does that ratio match one of the other ratios we have? It does. These are identical. This triangle is simply this triangle doubled. And look, the third side will match up as well. 5 and 10. 10 is simply double of 5. See, the third side followed through. So if you have a triangle and you're asked if they're similar, or if you have two triangles and you're asked if they're similar or they're to scale or they're proportional, take any two side, has to be the both sides on the triangles, put them in a ratio, make sure they're in the simplest form, compare. Done. As easy as that. Now, if they're nice enough to give you the angles in a triangle, and they're not always going to be that nice. But in this case, I also gave you the angles in a triangle. Just like with sides, you pick two angles. 30 degrees, 60 degrees, 30 degrees, 60 degrees. We already knew these two were similar. That makes sense. 40, 60. This angle is different from here and here. Unlike sides, angles actually stay the same. So if you have angles, it makes comparing triangles even easier. You don't have to do any simplification. You simply look at the angles. 30, 60 and a right angle. 30, 60 right angle. Proportional to scale, similar. Here we have 40, 60, 80. Not 30, 60 right angle. So this one is not like these two. These two are alike. They're similar. They are proportional. They're to scale. Questions? All right, now let's take a look at two more. Here I gave you rectangles. With rectangles, unfortunately, you can't use angles to compare them because on a rectangle, all the angles are right angles. So that's kind of not very useful. You have to use sides. Not a problem. Using sides is not difficult. And I only gave you two sides, so in a rectangle, you only have, technically, two sides because this one is the same as this. This two are the same, so you only have two sides. It makes it easy. So once again, I'm going to write them as ratios. The first one here, well, that's 3 over 4. That's easy. And again, I could have put the 4 over 3. Doesn't really matter. As long as you keep it consistent. If you put the bottom side on top, here you have to do it for every single other one as well. Now, what's the ratio I'm going to use for this one? 5 over 7. I'm going to put the left side on top and the bottom side on the bottom. Because I did that here. If I put 4 over 3 here, I would have to put 7 over 5 here. Just keep it consistent. Doesn't matter which one goes first, as long as you keep it consistent. What about right here? What's the ratio? It's 10 over 14. Now, next I have to put them all in simplest form. Simplest form or not? It is. Simplest form or not? It is. Simplest form or not? Not. What can I cancel from both top and bottom? A 2. 10 is 5 times 2. 14 is 7 times 2. So if I cancel a 2 from both, I'll get 5 over 7. Now, which two rectangles are similar or to scale? Proportional. These two. This one is not like the other two. It's not to scale with the other two. It's not proportional. It's not similar. These are similar. These are to scale. These are proportional. Pretty easy. Really it is. If you remember your proportions and ratios, this section is going to be a breeze. Questions? Alright, now I have some figures that we're going to try to see if they are similar to scale, proportional. They don't really mean the same thing. So we're going to see if they are indeed that. Let's look at the triangles on the top. I'm asking you, are they similar, are they proportional, or are they to scale? What would you do first? Well, what I would do is I would pick 2 sides to represent the triangle. You can pick 3 sides, but it's kind of hard to make a ratio out of 3 sides. You'll have something on top of something on top of something. So just choose 2 sides, and remember, if the 2 sides are proportional, the third side will have to follow. It doesn't have a choice in the matter. Here I have 2 whole numbers and a decimal. So I'm going to go with my whole numbers. I could have picked the decimal. No harm there. But why ignore perfectly good whole numbers when, you know, decimal? I don't like to work with decimals unless I have to. So I'm going to go ahead and do that. I'm going to set them up with this side on top, this side on the bottom. Preference. I could have chosen to be this on the top, this on the bottom. I'm just going to go with 3 over 4. 3 over 4 for this one. What would be the comparable ratio from this triangle? 6 over 8. Again, once you choose one set of sides and put them in a certain order in your first object, you just have to follow the same rules for the second object. Keep it the same. Follow the pattern. If you choose this side and this on top, this on the bottom, you can't go in and then for the second object choose this side and this side. You have to choose the same sides. So here it's going to be 6 over 8. Now, what do you do next? You put them in their simplest forms, the ratios. This one is, this one isn't. What can I do to this one to make it its simplest form? I can cancel a 2 from both top and bottom. 6 is 3 times 2, 8 is 4 times 2. So I can cancel a 2 from top and bottom, simplify this down into 3 over 4. Same ratios. They are the same ratio, which means the 2 triangles are to scale, they're similar, they're proportional. They all really mean the same thing. Questions? Then go ahead and work on the next one on your own. Again, you're going to figure out if these 2 rectangles, so the 2 objects, are similar or to scale. So go ahead, take about 1.5 minutes or 2 minutes and work it out. I'm going to pause this. All right, so what was the first thing that you guys did? What was your first step? Hopefully, you guys put the 2 sides, and the only 2 sides given here because it's a rectangle and not a triangle, into ratios. The only choice that you have realistically is whether you want to put one side on top or the other side on top. I'm just going to go with the 7 on top since it's already on top. But if you put 5 on top, it doesn't really matter. You're going to get the same answer. And here, I'm going to put the 12 on top. Again, I just have to follow the same rules. Then, hopefully, you simplified them down, which means there's nothing you can do for this ratio. It's already in simplest forms, 7 and 5. Nothing to cancel there. But here, 12 is 6 times 2, 10 is 5 times 2. They have a 2 in common. I can cancel that 2 out, and that yields 6 on top, 5 on the bottom. Simplest form. Are the 2 the same? Nope, they're definitely not the same. So what I'm going to do is I'm going to write down at the bottom here not to scale, or not to scale, or better yet, not similar. I like that word a little bit better. Not similar. I think that's better. Not similar. You can say they're not proportional too. I just like not similar. I'm going to highlight that or underline it. Questions? All right, take about 40 seconds and write this problem down. Yes, write it down physically with your pen or pencil. And can someone read this out loud? So here, you have a picture that you're going to put on the web. You guys probably have done this many, many times. Probably maybe even more than I have. And if you know anything about putting up pictures on the web, a lot of times you have to resize them because they might be too big. They may take up too much space. So resizing is something you do to pictures a lot of times when you put them on the web. So they're asking you, if you were to resize this picture, the original picture, and you don't want it to look distorted, all weird because, you stretched it too far in one direction. If you want to keep it looking the same, what must be the width of the new picture? Because they gave you the original picture, then they gave you the measurement of one of the sides, but they didn't give you the measurement of the other side. So think about this for a second, because we've done this before in the last section or something similar to this. What would you do? Well, I would set up my proportion or my ratios here and see what's the proportion. Because technically, I just have a missing measurement. I know one ratio, I know part of another ratio. We're being told we want this to be to scale or similar. So this has to be in proportion. So this is what I would do. I would set up my first ratio, which is 10:8. I would set up my second ratio, which is 3 inches tall, but I don't have the width. Now the 10 is the height in the original picture, so when I set up my new ratio over here, should the 3 go here or here? At the top, because 10 is the height and 3 is also the height in the new picture. So 3 goes here. And what about the width? Do we know what the width is? We don't. So we're going to make that into a variable. I'm going to choose W. With W makes sense to me. You could have chosen X or really anything else. What do you do next? How do you find your missing measurement? You cross multiply. We've done this before. It's very similar to what we've done before, so I'm going to go ahead and cross multiply. 10 times W. And all of this equals to 3 times it. All right. What's 3 times 8? It's 24, of course. So I have 10W equals to 24. What do I do next? I'm going to move this up a little bit. Divide both sides by 10, you say? I'm totally in agreement. Divide both sides by 10. And yes, I know, 10 doesn't go into 24 evenly, but you don't have to do long division here. What's 24 divided by 10? Should be easy. 2.4. And it's 2.4 inches. So to answer this problem, if you were to resize the original picture, which was 10 inches tall and 8 inches wide, the new picture has to be 3 inches tall and 2.4 inches wide to maintain the same proportions. So it's still similar, it's still to scale. Questions? All right, I'm going to give you about 40-45 seconds to copy this down, so I'll pause this. Go ahead. Can someone read this out loud for me? So here we have a model of a building, and this happens all the time when a building is built. There's a model constructed so that way the designers and the architects and the engineers can work on it without, actually building it first. So if there are any mistakes, anything they disagree on, they can change it on a model as opposed to building the building and then changing that. That's not very practical. So almost anything that's ever built in terms of buildings, there's a model that goes first and then the actual building follows. So they've constructed the model and it's 30 inches tall. All right. Then they gave you the scale. This is a ratio, and this ratio tells you what the scale between the model and the actual building is. And now they want the actual height of the building. Now this may seem like something we haven't done yet, but we actually have worked on problems like this. Because what is this right here? It's a ratio, 2 to 3. Remember, the column represents ratios when you have two numbers on either side. So this is a ratio of 2 to 3. Here, they gave you a part of another ratio, and they're looking for the other part of this ratio. And they told you that this is a model that's to scale. So you assume they're proportional. So you're doing the exact thing as we did in the last problems. You're going to set up your two ratios. So I'm going to go ahead and put my original ratio, the one that I know, 2 to 3, 2 inches to 3 feet, right here. And then I'm going to put the part of the other ratio that I know. I know that the model is 30 inches tall. Now, would I put the 30 at the top or at the bottom? I would put the 30 at the top. Why? Because 30 inches, 2 inches. 3 feet, I'm looking for the feet of the actual buildings. That's my unknown. And I'm going to make my unknown be F for feet. I guess, again, the letter itself doesn't really matter. What do I do next? I cross multiply. All right, that should be pretty simple. Should be an easy cross multiplication problem. Equals to 3 times 30. And what's 3 times 30? So 2F equals to 90. And hopefully by this point everyone knows I'm going to divide both sides by 2. So our final answer, F, is what? 45 feet. So the actual building, once it's built, based on the scale that they gave us, is going to be 45 feet tall if everything goes according to plan. So if the model was 30 inches tall and the scale is 2 inches to 3 feet, the actual building will be 45 feet tall. Questions? All right, we're done. Thank you very much.